solving a system of word problems. So we're going to use everything we learned from solving systems using all those methods and apply it to word problems. We're not going to go super deep into it. We're only going to spend one day on it because we don't have a lot of time until the end of the school year. So I kind of just want to graze this topic, introduce you to it, just so you have some exposure. Okay, so when we're solving system word problems, the very first thing you want to do is define your variables. Just like when we were doing regular word problems, you got to figure out, what don't I know? Okay, then you're going to set up two different equations with two variables. Remember, a system of equations has two variables, and we're going to solve by using whatever method you want to do. Okay, so in number 1, it says 4 bananas and 5 apples cost $3.56. And then it says 3 bananas and 4 apples cost $2.76. Find the cost of each banana and the cost of an apple. So the question or the very last sentence is always going to tell you what your variables are. Okay, so I underlined it, the cost of a banana and the cost of an apple. Those are the two things we don't know that we're trying to figure out. So I'm going to make those two my variables. So I'm going to say B is the cost of a banana. And let's say A is the cost of an apple. Okay, now those first two sentences are going to give me my two equations. So 4 bananas and 5 apples. Okay, that's going to give me a total of $3.56. So I'm going to say 4 bananas and 5 apples, right? So the B and the A are representing the cost. Well, you could represent the cost by however many you're buying. Add those together, and that's going to give me my total price. Okay, so that's my first equation. Now I'm going to look at the second equation, or the second sentence to get my second equation. So it says 3 bananas and 4 apples cost $2.76. So 3 bananas, 4 apples, and that was $2.76. Okay, so now that I have my two equations, you can either solve it using elimination, or you could solve it using substitution. I think that I'm going to go with elimination. So remember, with elimination, we want to pick a variable to get rid of. I'm going to choose the B. And so a number that I can make 4 and 3 match at is 12. So I'm going to multiply this top one by 3. And I'm going to multiply this bottom one by -4, because remember, they need to be the same number but opposite signs. Okay, so for the top equation, let me keep the colors the same. 12b plus 15a equals, let me calculate that out, times 3. So I get 1068. And then for my second equation, I get -12b minus 16a equals -1104. Okay, now that my b's are the same numbers but opposite signs, I can add my two equations together. So I get -a equals -36, and I'm going to divide by -1, so A equals 36 cents. Okay, remember, you could plug in A to any equation. It could be any of the first two or any of the second two, and you will get your answer for B. I'm just going to plug in A to the second equation right here to get the value for the cost of a banana. So 3b plus 4 times 0.36 equals 276. So 3b plus times 4, so 1.44. We're going to subtract 1.44 from both sides. So 3b equals 132. Divide by 3, so b equals 44 cents. Okay? So you don't actually have to write these ones as an ordered pair. Since it's a word problem, we're just going to say bananas equal 44 cents. Apples equal 36 cents. Okay, and then that's my final answer. So same thing you already know how to do. Now you just have to set up the equations yourself. With number 2, it gets to be a little bit different. So it says the Algebra 1 class voted to go to the Cubs game. Okay, they bought a total of 29 tickets, so we're going to keep that in mind. That's important. It says upper deck tickets cost $21 each and lower deck tickets cost $27 each. The total cost was $6.75. So I'm going to highlight these as well. We have 21 each, 27 each, and $6.75. Okay, how many of each ticket did they buy? So that's telling me my unknown. So when you're making your variables, you can't just say upper deck and lower deck. I don't know what you're talking about. I don't know if you're talking about the cost or if you're talking about the amount. Well, it says how many of each. So we're not talking about the cost. We're talking about the number of upper deck tickets bought. And then we could say L is the number of lower deck tickets. Okay, they're already giving us the cost. We're not solving for the cost. Okay, so this is where you need to be careful. So in the first sentence it said they bought a total of 29 tickets. So think about it. You want to add the number of upper deck tickets plus the number of lower deck tickets. That would give you the total amount of tickets that you bought, right? So I'm literally just going to put U plus L equals 29. Again, number of upper deck tickets plus the number of lower deck tickets is going to give me 29 tickets. Okay? The reason why I'm not bringing in the cost is because it's not telling me anything about the cost with the 29 tickets. It's just saying this is the total number bought. Now in my next sentence, I'm going to look at everything that I highlighted. Each upper deck ticket was $21 each. So I'm going to say 21 times the number of upper deck tickets. And then the lower deck tickets were $27 each. So I'm going to do 27 times the number of lower deck. Total cost was $6.75. Okay, so notice that it said equal to money, right? So in these types of problems, if they're talking about the total amount of money, then you need to add in the value of each ticket to get the total cost. Okay, if that makes sense. So money plus money equals money. Number of tickets plus number of tickets equals the number of tickets. So you got to be consistent when you're making these equations. Now for me, depending on the method, again, you can totally do elimination, but my preference in this one would be substitution, since in the first equation, U and L don't have a number in front of them, so it's pretty easy to rearrange that equation. So I'm going to use substitution. Again, you could do elimination and see if you get the same thing as me. I'm going to solve this for U. So I'm going to say U equals 29 minus L. Okay, so that's the equation I'm going to use, and I'm going to plug it into the dark purple equation down below. Okay, so instead of U, I'm going to plug in 29 minus L. Plus 27L equals 675. Okay, and I'm going to solve that equation. 10 times 29, so I get 609 minus 21L plus 27L equals 675. Okay, I'm going to move this over here because I'm running out of room. So I'm going to combine my like terms, and I'm going to move the 609 to the other side. because now I'm trying to solve for L. So I get 6L equals 66. So L equals, oops, sorry, not money. We already know how much they cost. 11 lower deck tickets. So all I'm going to do is plug in L into this equation up here, because U is already solved for. It's super easy to plug in L there. Again, you could plug in L any equation you want. It could be the light purple equation, the dark purple equation, or the green equation. You're still going to get the same answer, right? I bought a total of 29 tickets. Well, 11 of those are lower deck. Let me do this in a different color. So if I just do 29 minus 11, it's going to give me the rest of the tickets. So then I'm going to get 18 upper deck tickets. So we kind of want to write those out. 18 upper deck and 11 lower deck. And there's my final answer. Okay, number 3. These ones are pretty easy. So it just says the sum of two numbers is 325 and their difference is 25. Find the two numbers. So this is telling me what I'm looking for. That's what my two variables are, just the two numbers. So I'll say x is one number, y is the other. So I'm going to look at the sentences to figure out what my equations are going to be. So the sum, think of what sum means. That means addition, right? So if I add the two numbers together, I'm going to get 325. Now the second equation says their difference is 25. Remember, difference is subtraction. You guys always forget this. Some people think it's division. Difference means subtraction. So the difference between the two, it has to be x minus y, not y minus x, okay, is 25. And then I'm going to solve. So this one's actually already nicely set up for elimination because my y's are going to eliminate right away if I add these two together. So I get 2x equals 350. So x equals 175. Okay, and then if you want to figure out what the other one is equal to, you could plug it into any equation. I'm going to plug it into this one right here. So 175 minus y equals 25. Negative y equals negative 150. So y equals 150. Okay? And this one is okay just to circle your two answers. And I misspoke. Actually, it could be y minus x. It doesn't matter. You'll still get the same two numbers. Okay, so those ones are pretty much the easiest ones, but these are the three types of equations you'll see. So on the next page, I have a few U-tries for you to do. Again, so try it out. Solve it either using elimination or substitution. Do not use graphing because sometimes you get decimals and you won't get the exact answer. And then replay this and then see if you get the same thing that I do. Okay, so number 4, it says, on a fishing trip, Peter caught 24 fish. So it's nice to highlight the numbers that they're giving us. He caught some rockfish averaging 2.5 pounds. So they're talking about something different here. So I'm going to underline that in a different color. And then bluefish averaging 8 pounds each. Okay, so those are both talking about pounds. So I'm going to highlight that in purple. Their total weight of fish caught on the fishing trip was 137 pounds. Okay, so more pounds. So I'm going to keep that in light purple. How many of each kind of fish did Peter catch? So how many of each kind? So we're looking at the number of each fish. So my first variable is going to be R equals the number of rockfish. Oop. Okay, and then I'm going to say B is equal to the number of bluefish. Okay, and so they're telling me that there's 24 fish total. Well, wouldn't you add the number of rockfish plus the number of bluefish, and it's going to give you your total number of fish. So I'm just going to make that R plus B equals 24. Okay, notice that I highlighted things in light purple because they're all talking about pounds. Well, those are all going to create one whole equation for me. So 2.5 pounds per rockfish. So 2.5 R, and then it says 8 pounds per bluefish. So 8 pounds per bluefish, and that's going to give me the total amount of pounds, which I highlighted as 137. Okay, again, you could do substitution, you could do elimination. Since the last time with a problem like this I used substitution, I'm going to do elimination just so you can see that used as well. So I'm going to eliminate the b's. In order to do that, I got to multiply everything by -8. Okay, let me keep that on a dark green. So I'm going to get -8r minus 8b equals 160, and 8 times 4 is 32, so -192. Let me just check that I'm right. 24 times 8. Yep. Okay. So that's going to give me -55 when I add these two together. Okay, then I'm going to get -5.5 bar, and then my b is gone. So I'm going to divide both sides by -5.5. And so for R, I get 10 rockfish. Okay, again, you could plug this into either equation. I'm probably going to plug it into this top one because I know there's a total of 24 fish. 10 of them are rockfish, which means all you have to do is subtract 10 from 24, and I get 14 bluefish. Okay, let's label this. And then we circle our answers. Okay, so if they're giving you totals of something, it's always going to be your two variables added together equal to the total. And then they're either going to bring in money or they're going to bring in weight. And then you're going to apply that to your second equation. So bring in the cost or bring in the weight and then set it equal to the total cost or the total weight or whatever they're talking about. Okay, all of these are set up the same and you'll start catching on to the pattern the more you practice these. Okay, number 5. So this one is like number 1 in the examples. So the senior class is at Brother Rice and Marist, planned separate trips to Six Flags, blah, 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 blah. I'm going to skip to the end just so I could get my variables first. So how many students can each van carry? How many students can each bus carry? So that's my two variables. Okay, I'm going to say V, number of students in a van, and B, number of students in a bus. Okay, so these ones you translate as is. Okay, when it's saying like 9 this, 7 that, 10 this, 10 that. Okay, you're just going to translate like you see it. So what I mean by that is this first sentence is telling me there's 9 vans and 7 buses with 460 students. That is giving me my exact equation. So 9 vans and 7 buses equals 460 students. Now the second sentence is going to give you that same thing. So Marist had 14 vans and 14 buses, and that's 896 students. Okay, see how it just translates straight through the equation? 14V, 14B, 896. Okay, now in this situation, again, you could use substitution. In this case, I'm going to go ahead and do elimination again, and I'm going to eliminate the b's. So I'm going to multiply this top equation by -2. So I get -18v minus 14b equals -920. Okay, then my b's eliminate. I get -4v equals -24. So v equals 6 students. Now plug this into any equation. I'm going to plug it into the dark green first equation. So 9 times 6 plus 7b equals 460. So I get 54 plus 7b equals 460. So 7b equals 406. So B equals 58 students. Okay, so 6 students per van, 58 per bus. Okay, last one, number 6. Easiest one, I think. They're giving me the sum of the difference of two numbers. X is one number, Y is the other. Their sum, so when we add them, they have to equal 1,050. Their difference, when I subtract them, is 550. Easy setup for elimination. 2x equals 1,600. So x equals 800. Okay, again, you could plug it into any equation that you want. I'm just going to do it into the top one. So 800 plus y equals 1050. So y equals 250.